Welcome to VINDAL'S concept. We are not going to rush this class, so take time for us to deal with this. In the last class, we did what I called tetration, but this time, what I'm going to do is the application of the tetration. So we have this problem. So this is 2 is a superpower of x, which is a superpower of 3 is equal to 27. So this is what we call tetration. Remember, in my last class, I treated something like this. I said, if you have 4, superpower of 4 to 2, I said that this is the same thing as saying you are going to be raising 2 to power of 2 in 4 places. So this is going to be 2, 2, 2. All this. So we are stacking 2 in 4 places. That is called tetration. All right, now we have this problem. How are we going to be able to solve it? Now, let's get over it and get it done with. Okay, so at this point, I am going to express this 27 as a tetration or superpower to base 3. Now look at this. If I have 3 raised to power 3 is what? 27, right? But this one is like a power, so it is not this one. Now I'm not going to use this to write here because it is not the same tetration. So I'm going to use this, right? And this is same thing as what? 3 raised to power 3. Now, since they are the same thing, 3 raised to power 3 is what? 27. Therefore, I'm going to say that this is 2, which is going to be equal to 2. All right. Okay, now that I have made them to be in a tetration format or a kind of superpower, then I can now equate their powers, their superpowers. Because this is superpower, not just power. That is what we call it. All right, the next thing is going to equate them. So I'm going to say that 2, superpower of 2 to x is equal to 2. But remember that this 2 is something as what? X raised to power x. So I'm going to do this here. X raised to power x is equal to what? 2. Okay, at this point, the next thing I'm going to do is to introduce natural logarithms of both sides in order to bring this x, which is on top, which is the power, to bring it down. So I'm going to say, all right, so when we do this, I will now have, I'll have this. All right, let's take it step by step. So at this point, what else should I do? If I divide both sides by natural logarithm of x or ln x to both sides in order to make x the subject formula, remember I have messed it up. So the best thing is to do a substitution. Remember this. We have that e ln x is something as x. So knowing that this is true, that this will cancel this to have this, it's just like you saying 1/2 times 2. Okay? So you know that they are opposite, they cancel each other. Or if you have 1/2x times 2, so they will cancel each other and you have what? X left. So that's the same thing. So this will cancel this. You have your x left. So because of that, I'm going to write that here. So I'm going to say e ln x multiplied by ln x, which is equal to ln 2. All right, so because this x is now substituted as e to the power ln x. So this is how we have it at this point. Now, what are we going to do? So let us manipulate it, because there is another principle I'm going to employ here, which is called Lambert W function. Lambert W function. So if you have this Lambert W function, it says that if you have e x to e to the power x, that its W function is going to give you x. So that means that I can only employ this Lambert W function if I can have a particular factor or number e to a power which is the same with this. So this and this must be the same thing. Its Lambert W function will give me just the letter, which is the power. So the same thing goes if I have this p e p, answer is going to be p. So this is what we call Lambert W function. So I'm going to write this to look like this so that I can apply the Lambert W function. So I'm going to have ln x e ln x, so which is equal to ln2. So look at this. So I can now bring in my Lambert W. To do that, I will now say that Lambert W function of both sides, because I can't do it just one side. I'm going to do it to both sides. Ln x e ln x is equal to W function of ln2. So when I apply this W function to the left hand side, what am I going to have? I'm going to have what? Ln x. So this is going to be ln x, which is equal to W function of ln2. All right, remember I'm looking for x. So I have to go back to this. So I'm going to take e of both sides. So I'm going to put e to this and e to this. So this will cancel this. I have only x, which is equal to e W function of ln2. Oh my God. So you may think, what is this? It's mathematics. And there are calculators or some computer functions or appliances which can handle this, which has W function. So when you key in e to the power of W function of ln2, you are going to have a value of x, which is true for this. Thank you for being part of this class. Please don't forget to hit the subscribe button, like this video, comment, and please share it. Bye.